Okay. Save this link. This is GitHub. Okay, slash Swapnil Saurav. Okay, so github.com Swapnil Saurav, and then you have data set. Okay. Anyway, I'm going to share this link as well. So it has like a lot of data sets, and we'll be using these data sets to practice. So there are two data sets. Okay, one is this Swapnil Saurav slash data set, and another one is GitHub slash Swapnil Saurav slash machine learning. Okay. So for machine learning algorithm, we'll be using these data sets. Okay. So you can save these links. Anyway, I'll update it in the same blog site as well. You'll be able to pull these links. Okay. Now, one thing is that Pandas can read this data set directly. You don't have to download. You can just point the link and it can read the data set directly. Or if you want to save it on your local drive, you can go to this link, data set. Okay. And you see this code here, right? And do you see this small screen here, download zip option? Do you see? Does it appear on your screen?
Yes.
Right? Okay. Click on this download zip. If you click on this, all this data set, it will be available on your local drive and you can use it even without internet. But if I were to read it, um, let's say there is here couple of, yeah. You see this user device and user usage. So now we will use these data sets to actually perform our merge. Okay. So if you click on user usage and if you click on user device, the table will open here. You see this? So this is your user usage CSV, and it has 4 columns: outgoing minutes per month, outgoing SMS per month, monthly MB, and use ID. Okay, so each row has a column called use ID, and this is your unique value. It's like a primary key for this table. Okay, so unique value. And then you have one more data set here called user device. Now, user device has use ID. So this is how you know that, you know, user device and user usage, these two tables are linked. Okay. User usage and user device, these two tables are linked. And of course, okay, this is use ID and these are, other columns, right? So you have user ID, platform version, phone type, and your use type. Okay. Okay. So here you have these columns. Now we need to merge. Okay. How many types of merge did we see before? That's the question. How many types of merge do we know?
Three, sir. Yeah, no, wait, four, right? Are you talking,
Default. Sorry, go ahead.
are you talking about like inner join, that like,
Yes,
yeah, inner join, full join, right join, left join?
correct. So we have inner join, right? We did outer join or full join, right? Then we have left join, we have right join. Okay. What does inner join mean? So see, in this table, you have use ID, which is the common column, okay, which connects these two data sets, isn't it? So what inner join is saying that only the common values between these two tables will be taken. This is like intersection. So if your table 1 has use ID like 1, 2, 3. And if your table 2 has use ID like 2, 3, 4, okay, so inner join will give us what?
2 and 3.
3 and
Yes,
4.
2 and 3. Inner join will give you
Oh, sorry, 2 and 3. Yeah.
2 and 3, correct? Yes. Now, if I have outer join, what will outer join give us? Outer join will give us all the,
All the values.
yes. So you will get 1, 2, 3, 4. Okay. And the columns for which 3 is not there, 1 is not there, will be null in case of T1. In case of T2, so T2 doesn't have 1, right? So T2 will have null for, row 1. So here, how many columns are there in T1? Okay, so T1 has 4 columns, right? That's what we saw, 4 columns. And T2, let's say T2 is user device, has 3 plus 3, 6 columns. So this has 6 columns. And let's assume 3 rows. This has 4 columns. And let's assume it has 3 rows. Now, when you join them together, how many columns will we get together?
Four rows.
No, columns together.
Columns. 4.
4 columns.
6
10
plus 4, 10 columns.
Oh, like
But
that.
but one column is common, isn't it?
uh,
So you'll get only
9
9.
columns.
Yes. So inner join will give you 9 columns. Okay. In fact, all join will give you 9 columns. So whether it is inner join or outer join or left join or right join, all will give you 9 columns. Okay. Rows, yes, inner will give you only 2 rows. Okay, because only 2 rows are common. Outer join will give you all the possible rows. It's like your union operation, all the possible rows. So you get 4 rows, right? And the columns for which there is no value for 1 will have null. Columns for which there is no value for 4 will have null. Okay. Now, our left join. What is left join? So here the importance is given to the table that appears on the left side. That means when you write a query, SQL query or Pandas query that we'll write in some time, you will end up writing one of the table first, right? So if I say T1 join T2, okay, then which is left table? T1. The first table that you write in the query, that becomes your left table, right? Because T1 is on the left side of T2. If you write T2 join, both are same, okay? It's not different. So if you say T2 join T1, in this case, T2 has become left table and T1 is right table, okay? So what it says is you'll get same number of rows as left table. So if left is T1, you will get all these 3 rows only, okay? And again, of course, columns which does not have 1 will have null. Right join, the table which is on the right side. So T2, so you get again row 3 rows, but you get 2, 3, 4. Okay, you get 2, 3, 4. Okay, so your 2, 3, 4 will be the resulting rows, and of course 4 column will have null values for these 4 columns, right? So this is how we perform join, and we have seen already in SQL, right, how to perform these joins: inner, outer, left, and right. Now let's go back to data set for a second. And what you notice here that this is the data set, right? Now we need to read it. Okay. So we cannot read this link because this link has all this extra text. Okay. You have browser here, you have all this extra link here. So we cannot read this page. So each of these GitHub page data set will have raw version. So click on this raw. Okay. When you click on this raw, it will take to a raw page where you only have the data, no extra text. Okay. Sometimes when it is taking time, that means it may not be available for us to read. It's taking time. Because sometimes, I don't know, it's with only me, or you might also see same thing. Sometimes this raw version is not available. Okay. Sometimes it's available, sometimes it's not. That's why it's better that you download and keep it in your local drive. Okay. That will be easy to pick. Okay. Yeah, it's taking time. That means, it's not going to work. But when you click on raw version, right? Okay, you get this link. Okay, when you get this link can be directly used by Pandas to read the data set. Now it's not working, so this link will not work. Let's see. Let's try. Okay, it's saying that, connection lost or something. Let's go back to our PyCharm. Okay, as usual, we need to import Pandas as PD. Okay, now you can simply say pd.read, okay, CSV. pd.read CSV and give this raw link. Okay, and you will be able to read the data. So, okay, I'm not sure. So I'm going to, this is user device, right? So I'll say user device df, data df, user device.df. Okay. Now, if this link, okay, is available, we should be able to print the data set uddf. So I'm going to click on P1, run. Okay, see, it's taking time again. That's it, no? You can download and keep it. Let's see if this doesn't work. I'll go to my local drive. Okay. Meanwhile, let me go and see the path where I have on my system. But this link, if data is available, okay, you can directly read it from here. You don't have to download it. Okay, so see, it says URL. It's not able to open the link. Okay, so what I'm going to do, I'm going to delete this link. Okay, instead go to my drive. So as I said, you can give double. One backslash will not work. Backward slash will not work. Either you give two backward slash or you give one forward slash. Okay, just like Mac. So if you're using Mac, you have to give one forward slash. For Windows, forward slash will work, or you can give double backward slash. Okay, now let's read this and see. So yes, you see, this is our user device data frame. Okay, so user device data frame has user ID, user ID. Okay, now it will show only 4 columns. Okay, by default. So you see there are only 4 columns here, and rest of the column is hidden. Like you'll get first 2 and last 2. Middle all are saying dot dot. Okay, when you see dot dot, definitely there are some columns in between. Rows, first 5 and last 5. Again, you have dot dot. Indicating there are more rows in between. Okay, so this is the default view and it will show you the shape. This is called shape. So you have 272 rows and 6 columns. Okay, 272 rows and 6 columns. So if you want to just see the size or how many rows and columns are there, you can say print uddf dot shape. Okay, dot shape will tell you, okay, how many rows and columns. What is the output here? In what format you have output? What format is this, guys?
Tuple.
Tuple, yes. So when you get this output in tuple format, okay, you can, of course, use it all the learnings that we have done in tuple, right? So if you want to know only the rows, you simply say shape square bracket 0. right? If you say square bracket 0, you will get only rows. So I can say here something like this, rows, okay? And if you have to know the number of columns, what will be the value here for columns? Shape of 1, okay? So shape of 1, you get number of columns here, okay? So this is how you can get the number of shape for pandas, okay? Now we are working to, let's see how to merge these two pandas together. Okay. Now before that, if you want to see, first 2 rows, first 3 rows, or last 2 rows, last 3 rows, okay, we have something called as head. There is a function in pandas called head or tail. So if you want to see bottom, last 5 rows, so I'll say print udf dot tail. Tail, if you say, so by default, it will show you last 5 rows. Okay, you see, these are the last 5 rows. Okay. If you want to see last row, you say tail of 1. Tail of 1 will give you 1 row only. Okay. If you say tail of 10, tail of 3, tail of 8, it'll give you that many number of last rows. If you want first row, you can say print uddf dot head and head of 1. So head of 1, you can see the first row only, right? You can see index 0 here. Index 0 indicates first row, right? So yes, so you can use head and tail to filter out the data, okay? But you can only filter the first or last, like, from last how many, from first how many, okay? Yeah. Now let's read the second data set that we have. So that was use ID, correct? So I'm going to say here, we'll use it, use df. And here you have, okay, use, user usage, right? Sorry, yeah. User usage. User usage is the table. So we did user device before, and this is your user usage, isn't it? User device and user usage. So now I'm going to say print, okay, use df. So this has 240 rows and 4 columns, correct? So this has 240 rows and 4 columns. And this one had how many rows? 272 rows, right? 272 rows and 6 columns. Okay, now it's time to merge them, right? So how do we merge? We have a function called as merge, okay? So if I say result df, okay, result df equal to pd dot merge, okay? So if you are merging two tables together, you have to say pd dot merge, okay? You are merging two tables together, you say pd dot merge, and then you give the table, okay? Which table, okay? So here I have UDDF and useDF, okay? It depends on you which one you write first, okay? So if I write useDF first, then which is my left table? UseDF has become a left table, okay? And UDDF would be my right table, okay? So I'm saying useDF and UDDF. Now here, if I take both the table name, okay, that means you are saying that you want to include all the columns from table 1 and table 2 into merge. Or rather, we should use the word data frame, right? We are taking all the columns from this data frame and this data frame and putting them together. So we want to merge these two data frame together. That's why we are saying, okay, we are taking that just the data frame name. But if you want to restrict the columns, okay, you do not want all the columns to take part in the merge. Okay, you can go ahead and, okay, you can say here, in the square bracket, give the list of columns that you want to include. Okay, now what I'll do purposely, uh, okay, let me put this on use df, because use df only 4 columns, right? And I'll use all the 4, you know. So in a way, we are using all the 4. Okay. So let's first put use ID, not required, but let's first put it because this is what we are going to merge on, right? So use ID, then I'm going to say second column, third column, and fourth column. So monthly MB, okay. And you can see the output as well, how it is shown. So I'm saying add on these 4 consoles. In a way, I have taken all the 4 columns. And here I have not mentioned anything. So all the 6 columns will be taken into merge. Okay. So result equal to pd.merge. Okay. Left table comma right table. Okay. And now you have to say on which column. Okay. On equal to. On equal to. Okay. Which column are we merging on? What should I give here?
Use ID.
Use ID. Yes, use ID is the common table which we want to merge on. So you'll say use ID. So I'll use ID. Now see, in this case, I have not told whether it is left or right or inner or outer. Okay, I have not mentioned. So what will happen here? What will happen here? Come on, guys, you have done all these things before.
It will take inner join.
Inner one. Inner join is the default one. Okay. When you don't mention, the default is inner join. When you write where clause without saying which merge, it does the inner join. It'll give you the inner join. Now, how do I know? Okay, I'll print the result. How will I know it has done inner merge? What is one way to test that it is inner merge? Okay, we get some result. Let's suppose if the if query is correct, there's no syntax error, we'll get some output. How do we know that the output is for inner merge? Look at the number of rows. How many rows do we get here?
All the
Number of rows is that's the only thing that is different. Column we said that it will be 6 plus 4 equal to 9, right? You get 9 columns. How many rows do we get? In inner merge, you will get lower than the lowest value.
40 rows we get.
So you will get less than 240 rows. Okay, because if one row is common between them, let's say if one is common, then it is 239. If none of the rows are common, then you'll get 0. Maximum 240 rows can be common. Okay, because this is 270, this is 240. Maximum 240 rows can be common. It's only between the common rows you will get, right? So so maximum 240 rows can be common. So maximum rows you can get is 240. Minimum you can get is 0. Anywhere between 0 and 240 you will get. Okay, so it will be less than the number of lower rows here. So if you get less than 240 rows, that means it has done an inner merge. Right? Okay, 159. That means it has done inner merge. If you get exactly 240, then it's left. If you get exactly 272, then it's right. If you get more than 272, it is outer. Less than 240, it is inner. So what does 159 rows indicate? How many rows are common? It will give you only the
159
common.
rows.
Yeah, so it will give you only
159.
common rows, right? So 259 rows are common. That means, your UDDF is the first one, 272. So how many? So it has like 159 common plus how many a different one? So 72 plus 41. 72 plus 40 is 112 plus 1, 113, right? 113 they have, this column does not have values in other table. Now, if you talk about UseDF, has 159 common plus 240 minus 59. 40 plus 41, 81 rows are different, right? Okay. So if I do outer join, total how many rows will I get?
One 159 plus 113 plus 81.
Correct. So these two anyway is 272. So 272 plus 81. That many rows you will get for outer join. Okay, let's run it and see. So okay, so when we don't mention anything, okay, so it's okay, so it is inner join, right? And see number of columns you got 9. Okay. Now here, okay, I'll say PD merge use DF, and you have one more parameter here. We say how. Okay. In how you have to mention, okay, whether it is inner, whether it is right or left or outer. Okay. So here I go and I say outer. Is it outer? Let's see. How many rows we got? 353. 272 plus 81. 272 plus 81. What's the answer? Yes, sir. What we just performed is outer merge. You see, 353 rows. And the first columns here does not have the values here, right? So it got NaN. Initially, you'll have NaN here. Okay, so the columns, okay, which does not have values here, because we have only 240 rows in one table, but we have to generate 353. So remaining 81 will have null values in those 4 columns, right? So this is how you say outer. If I have to do left, you simply mention here left. So how many rows we get for left? Use DF. Use DF is 240. So here you'll see you'll get 240 rows. So it has done merge on left table. Similarly, you can do merge on right table. Okay. So how? I'll say right. So right will be on the right table, which is on the right, UDDF. UDDF has 272 rows. So you should get 272 rows here. So this is how your merge works. Okay. So with that, we end our discussion on pandas. Okay. From now on, whatever we'll do, we will have to use pandas, right? So we are going to do data analysis, machine learning algorithms. So we'll have to use pandas itself. Now, if you want, you can try one example. We have 20 minutes or so, right? So let's try one example here. Okay. So I have, okay, I'll put it here. I'll move to a new file. Okay, I have a data set called hotel booking. Okay, so import pandas as PD. And let me go to this file and copy this link. And I'm going to put it here. So this one has hotel booking. So you can type hotel and you can see. Okay, they're in the same data set. Okay, so if you download that entire um, dataset.zip, you'll be able to access all these files. Okay, so yeah, so I have I have now access to this. Now, if you want to know the number of shapes and what are the types of each column, okay, so print. Okay, let me call it as just df, simply df data frame. So I'm going to say df dot shape, right? So this is going to give you number of rows and columns. You can say print df dot d types. D types mean data types. Okay, so it'll tell you the data types of each column. Let's run and see. So yes, you see this has, okay, 1,19,000 rows, 1,19,390 rows, and it has 33 columns. And these are the column names and data type. So ID has integer value. Hotel has object. Okay, so object means it could be string. Is cancelled is float, lead time is float, arrival date, year. This is just the year. So you have year, month, week, number, day of the months as in separate columns. Okay. Then number of stay in weekend nights. Okay. So this is a data from a hotel booking, and this talks about the passenger, the customers who have stayed in the hotel and when they arrived, how many weekend nights they stayed, how many weekday nights they stayed. So if they stay, let's say on Friday, Saturday, Sunday, let's say you stay in hotel so it'll count it as 2 weekend nights and 1 weekday night. How many adults were there? How many children were there? How many babies were there? Okay. Again, male is object type. Now, it is very difficult to display all the 33 columns here, right? But I can show you on GitHub itself. So if we go back to GitHub, okay, H hotel. Let's say Control F, hotel bookings. Yeah, here using. Okay, so yeah, so say it is so big that even this is not able to display. Okay, so what we'll do, we'll go back to our folder. I'm going back to folder. I'm going to open this Excel file, CSV file, and then I'm going to share it on the screen. Just give me a second. Okay, so this is the table that we saw. ID, hotel. Okay, so this is the hotel name. It's called Resort Hotel. This is cancelled. I mean, was booking cancelled? So if booking is cancelled, it will be 1. 1 means yes, 0 means no. Lead time, how many days before arrival date did they book it? That's lead time. Arrival year, month, date, week number, number of stays in weekend, number of stays in weekday, number of adults, number of children, number of babies, okay, meal type, country, okay, Portugal, Germany, okay, USA, Spain, Ireland. Then you have market, okay, market segment. So was it a direct booking to hotel, or it was a corporate booking, or through a third party? Okay, online TA. So was it direct? So they would have come to the hotel website directly and booked it, or through a third party, or through a corporate booking. Okay, so you have all these columns. Okay, so let's go back to our PyCharm and let's practice some data frame concept here, or Pandas concept here. Okay, so this is how you can see the data type of each data. Now, okay, if you talk about data types, okay, we come across data types such as numeric. So numeric will be your integer, float, etc. Okay, this is called numeric data. So number of adults, 2. Okay, number of children, 3, right? That's an example of your numeric data. Then, okay, we say categorical data. Categorical data is categories, set of categories. Okay. Now this is different than numeric, obviously, because two things. One, mostly this will be text, but this doesn't mean text. For example, gender. If you say gender, male and female, okay, though it is text, but it is really not a text. It we can it's a structured data. Text becomes unstructured data, and your numeric becomes structured data. Categorical becomes structured data. So male, female, right? So this is not a number, but this is just a representation. And all the columns in that, all the rows in that column, okay, will have either male or female, right? Let's say you saw that booking type, right? Three booking types: direct, online TA, or corporate. So there also you have three possibilities. So all the 1,19,000 rows has one of these three values only. It cannot have fourth value. That's why we say categorical. One of the categories. Okay. So if you look at the unique values, you get only three. Okay. So that's called categorical values. Now, so again, like if you talk about region, north, south, east, west, right? Car manufacturer, right? So when you see these values, and if the value repeats, okay, from given set of, now it could be 50 set of values, right? Car manufacturer in the world, it could be probably 100 car manufacturers, okay? But those 100 will only repeat, right? It becomes categorical. Categorical has again two types. One is called nominal categorical value, nominal, okay? And then second one is called ordinal, not P, ordinal. Ordinal where order is important, okay? Here, there is no order as such. So it will be done in alphabetical order. If we talk about male, female, for example, okay, male, female, doesn't matter whether male comes first or female comes first. Right? Car manufacturer, it doesn't matter whether, company A comes first, company B comes first. Okay. Region, north, south, east, it doesn't matter whether north comes first, south comes first. So in such case, what we do, we generally arrange in alphabetical order. Second is ordinal, where order is important. Now, for example, rating. Okay. I'll say rate today's class. Now you can rate it as excellent or very poor, right? So you have very poor, poor, average, good, excellent. Now, when I'm talking about these values, I cannot say, okay, rate, very poor, excellent, poor, good, average. It has to be in order, right? It has to be in very poor, then good, then, sorry, average, then good, then excellent, right? Here, order is also important, the way in which you ask the user to rate, right? Education qualification, right? It has to be in a order. Generally, it has to be in increasing order. So we know that, okay, poor is less than average. Poor is greater than very poor. By how much we don't know. Okay, but we definitely know the order. Okay, you get excellent rating, you're happy. If you get poor rating, you're not happy, because there's a meaning associated with that. But not so in case of nominal, right? Okay, male, female, or region, or company names. These are not your example. The booking type itself in this example, online TA, direct, or corporate, doesn't matter which comes first, right? Because all three are equally important for the business, right? But rating, okay, is again categorical, but their order is important. So we call them as ordinal categorical data. Okay. So you have numeric, you have categorical, and you can have text. So mostly for our next few classes, we will avoid text data. Okay, that becomes unstructured data. Towards the end, we will see how to handle unstructured data, how to handle time series data. But for next few days, we will only focus on structured data. So structured data means it will be either numeric or categorical. Okay. Even time series comes under structured data only. Okay, but text becomes unstructured. Audio, video files becomes unstructured. Image becomes unstructured data. So we'll do it later towards the end of our course. We'll talk about how to handle unstructured data. Okay, so you're able to read this. Now, you want to divide this data set into, let's say, number and non-number. Okay. So I'll divide this data set into numeric and non-numeric, let's say. So I'm going to say df underscore numeric. Okay. So this is data frame which will only have all numeric columns, let's say. So I say df underscore numeric, I'll say df dot select. I'm selecting the subset of columns. Okay, I'm selecting subset of columns. So I'll say select D types. Okay, select data type, and I'm going to say include equal to your list of values you can give. So here I only want numeric data. So I'll say NP. Okay, so NumPy. I have to use NumPy. So import NumPy as NP, and I'm going to say NP dot number, NP dot numeric. Okay, so it should be NP dot numeric. Let's see. Okay, I do that. And now if you want to, okay. Now what I'll do here, I will, let's print this and see what happens. Before I perform anything, let's print this. Has no attribute. Yeah, it is number. I don't know why number was not coming, but numeric was coming. Number is the attribute. Okay. So see, it has given us, okay, how many columns we got? 21 columns. 21 columns out of 33 columns. That means if you count them here, okay, so this is number 1, 2, 3, okay, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So see, there are 21 columns which are numeric. So you can get numeric columns only here in df numeric. Okay. Now, how do I get number? Or sorry, not number. Number we got it right. I want numeric, categorical, or let's say non-numeric. Okay. Here it's anyway. See, we have not converted into category. We can convert. We'll see later how to convert into categorical. But it is object type right now. Okay. It is read as text. Okay. So Pandas will not know whether it's categorical. You have to say it is categorical. So by default, it has read as object. Okay, object could be anything, and here it is text object. So if I have to do this, I have to say exclude, right? What I'm saying is exclude number. So if you exclude number, obviously non-numbers will come here, right? So df categorical, and now if you run it, we should see how many? 11, right? 12. 33 minus 21, 12 columns. So these are the values. So date is also read as non-numeric, right? As your non-numeric. So you have date, and so this will not have just categorical. Okay, so I'll say df object. Okay. So this will have your categorical and date columns. Okay. One last thing we'll do before we wrap up today's session. I want to see number of missing values in this column. I want to see number of missing values in this column here. I can say for call in, okay, df dot columns. Okay, now df dot column, okay, will give me access to all the columns. Okay, so if you want to print it, you can print it. Before, did we not use here? No, we used only, yeah. So you can say here print df dot columns. Okay, so you get all the list of all the columns here, you see, as a index here. Okay, so see ID, hotel, is cancelled, lead time, arrival date, etc. These are all your columns. So I'm saying for column in df dot columns. Okay, I want to see the values missing. Okay, so I'll say missing equal to, okay. Now, how do I find missing value? Okay, so I will go through each column. Okay, and you have 119 rows in total. I'll check how many of those rows in each column are missing. Okay, so if I perform mean of, okay, column is null. Okay, so df, okay, of coal. So coal will be each value, right? In a loop, ID first, then hotel, then is cancel. So df of ID, df of hotel in the next iteration. Third iteration, df of is cancelled. So I'm reading age. Now I'm going to say dot is, sorry, is null. Okay, is null. So it will find all the null values. Now if I find the average, so I'll say np dot mean of null. Okay, and okay, now if you multiply this with 100, it becomes percentage, right? Okay, so if you simply want to print, you can say something like this. Okay, I will say format string, here column, and here let's say I just give the values. Okay, missing. Now when you run it, okay, you see it says ID has 0 values missing. Hotel has 0 values missing. Is cancel has 8.3 e power 0.5 means 0.00, very little value missing. Multiply by 100, you get percentage, right? Arrival date is 0.0, that means there's no missing value here. There's missing values here, here, here. Okay. If only want to display the missing values, I can put another loop here or condition here rather. If missing greater than 0, only then you print. Otherwise, you don't print. So now when I run it, I will only see the missing values in this. Okay, so see ID and all those things which had 0 missing values should be gone, right? Yes, all the 0 is gone. So these are the missing values in this column, and we will learn next, okay, when we talk about it later, okay, how to use it for, how to use it and create, how to replace missing values with, what strategy we adopt and things like that. That is part of our analysis that we will do. Okay, so with that, we complete our pandas, core pandas, and we'll stop here for today.